Using the Kanban card formula is a question of finding all the components to plug into that formula. This particular scenario is good practice in that. Let's take a look. The fabrication department provides a component for the assembly department. The assembly department's usage of that component, now notice the information, usage of that component is 4,800 units per 8-hour day. The fabrication department fills each container with 60 units in 40 minutes, and there is this 20% cushion built into the system. The question, how many containers or Kanban cards should be used for this component, is an invitation to use the formula. D times L times 1 plus x divided by c. But we have to find the appropriate numbers to place in the position of each one of those parameters. So what are they? Okay, the D is the demand or the usage rate for a particular component that's being governed. Now, we were told information about that. Where is it? They said that the assembly department's usage, that's what we're looking for, how fast, whatever's going to be governed by this Kanban card, how fast is it being used up? There's the information there. It says 4,800 units now per 8-hour day. 4,800 per 8 hours. I can clean this up, and I probably should. Just logic. That is 600 an hour. Okay, fine. I found a number for right there. Now, what is the next parameter that we're looking for? L is the lead time on the container, right? How fast it takes to conjure up a new container full of this component. And there was information here. The fabrication department fills each container. That was the hint, with 60 units in 40 minutes. There, the turnaround time. Okay, so it found that, right? What else do we need? We need X. Oh, X is that management coefficient, right? The cushion, okay. 20% is 0.2. We needed, the decimal form of it to put there. Got that. We need one other parameter, that's C. C is the container size. If they fill each container with 60 units, that must be its size. There, I think we have everything that we need in order to execute this formula. The number of Kanban should be, now you say D equals 600 an hour times, don't write 40. Don't write 40. There's only, at this point, really one thing that could go wrong, right? And we're just going to make sure that it does not go wrong. Remember with this formula, D, the usage rate, and L, the lead time, the turnaround time on a container, they need to be stated in the same time units, or the formula does not work out rationally. You get the wrong answer. Okay, right now I write 1600, meaning 1600, or 600, meaning 600 an hour. At the point that I wrote 600 down in ink, I obligated myself to state the lead time, the turnaround time on the container, in hours. Okay, 40 is 40 minutes. Now, no problem. Minutes are really easy to convert into hours. Let's see, 40 divided by 60. Well, it's basically 40 minutes is 2/3 of an hour. 2/3 is what I want to write and use here. 600 times 2/3 times 1.2, right? That's all the numerator, divided by 60. So I get this across the top here is 480. 480 divided by 60. The result is 8. Ah, there's the answer. Given everything that was described up here, how many containers, if they're specially marked, or Kanban cards, if that's the signaling system, how many do you want to devote to this particular component? 8. All right, now, what's the next question? Next month, the fabrication department expects its own usage of the component to fall by half due to an expected decrease in sales of the finished goods requiring the component. Okay, assuming this change is permanent, how should the number of containers or cards used to control this component be adjusted? So the key to this question is to recognize what just changed, because we already calculated the number of containers or cards, had an 8, and then they said, oh, there's this thing going on where the finished good is going to be less popular. And what part of this is changing? The part of this is changing is not the container size, not the management policy, not the amount of time that it takes to turn around a container. It's D, the usage rate. If people want less of the finished good, then this company is going to be using less of that component. Oh, okay, so we need to make that change. Now, what is it that they said? You know, what's the new D? Well, the old one was 600 per hour. And they said that they expect their usage to fall by half. So, right, we just want to divide it by 2. And say, all right, our new D is 300 an hour. Everything else is the same. Everything else is the same, so why don't I just work the formula again, but with a 300 times 2/3 times 1.2 times across the top, divided by 60. So I get that's like 240 across the top here, divided by 60, or 4. Now that we've found out that the usage rate of the component will drop by half, our recommendation for the number of containers or cards that should be dedicated to the production of that component drops to 4. And interesting, notice that it drops by half.